In this video, I'm going to show you a couple of identities for sine and cosine that are referred to as double angle identities, okay? These might not be quite as powerful in the sense that they'll allow us to find, for example, some difference identities, we were able to find the sine of 75 or the cosine of 105 or different types of measurements that we couldn't find before. This is basically going to allow us to find the sine or the cosine of double an angle, okay? However, that being said, it needs to be double something that you know how to find. So for example, doubling sine of 30, we'd be talking about a 60-degree angle. That isn't something that we don't already know. Doubling a 45-degree angle gives us a 90-degree angle, which is something we know how to work with. Doubling a 60 gives us a 120, which we can work with. So these aren't necessarily super useful for finding trig values, but they are used in a lot of trig identity problems in higher level courses. So they're still pretty important, and they give you alternate ways of writing different statements. So let's take a look at this. If I want to take sine of twice an angle, okay, that's the same thing as taking that angle plus that angle, okay? So having a theta plus a theta, or an x plus an x. And what that really suggests is that I can really use the sine sum formula, but instead of having two different angles, x and y, or alpha and beta, I'm just gonna have the same two angles. So you take the sine of the first angle, so I'm gonna change this to sine of theta plus theta. So you take the sine of the first angle times the cosine of the second angle, plus the sine of the second angle times the cosine of the first angle. And if you notice, I've got sine of theta, cosine of theta, sine of theta, cosine of theta twice. I have two of the same thing. Those are like terms, so I can just add those together, and it turns out that if you want to take the sine of twice an angle, that's the same thing as taking twice the sine of an angle times the cosine of that same angle, okay? So if I wanted to find the value of cosine of 60, for example, let's say I didn't know how to do that, I could actually take the sine of twice 30 to get the sine of 60, okay? And the formula says I could take twice the sine of 30, which is 1/2, times the cosine of 30. That's radical 3 over 2. That's 1/2. You multiply by 2, and you just end up getting radical 3 over 2 when you simplify the whole thing, okay? So again, it doesn't get used a lot to evaluate things, but it's a pretty important statement nevertheless, okay? Cosine for 2 theta is a little bit messier, okay? And let me show you why. So same thing, I can say I'm going to do a theta plus a theta here, okay? If you remember the cosine identity, you take the cosine of your two angles first. So that's going to be cosine of the first angle, theta, times the cosine of the second angle, theta. Remember, for a sum, you subtract the two angles, and then you take the sine of your two angles. So that's going to be sine of theta, all right? Well, if you take a look at this, cosine's being multiplied by itself. That's really cosine of theta squared. That's really sine of theta squared. So I'm going to rewrite this a little bit differently. I'm going to write this as cosine squared of theta minus sine squared of theta. And by the way, you have to be really careful because sine squared of theta plus cosine squared of theta is equal to 1. Okay, that looks a whole lot like that. So you have to be careful now. If you just see a sine squared and a cosine squared, you can't just assume it's going to be a 1. You need to figure out, are they being added or are they being subtracted? But anyway, same kind of thing. If I wanted to find the cosine of 90 and I knew what the cosine of 45 was, for example, cosine of 90 could be found by taking the cosine of 45 and squaring it and subtracting the sine of 45 and squaring it. And let's see, that would be radical 2 over 2. If you square that, that would be 1/2. And that's going to be radical 2 over 2. And if you square it, that's going to be 1/2. 1/2 minus 1/2 is equal to 0. Okay, and if you think about it, cosine of 90 is in fact equal to 0. Okay, so that's something that you can do there. Now, there are other variations of this one. This is pretty much the standard you're going to see for sine of 2 theta at all times. For cosine of 2 theta, there are actually different variations, and here's why. Remember that sine squared of theta plus cosine squared of theta is equal to 1, okay? So that means, for example, Cosine squared of theta, if I subtract sine squared of theta from both sides, cosine squared of theta is the same thing as 1 minus sine squared of theta. Okay, so I could go into this statement up here and replace the cosine with a 1 minus sine squared of theta. Okay, if I replace this with a 1 minus sine squared of theta, and then I subtract another sine squared of theta, what you'll notice here is I have 2 sine of theta values. So that would be 1 minus 2 sine squared of theta. Is another way of writing the cosine double angle identity. Okay, and by the way, this one's nice because you just need to know the sine, and you can put it in, and you can find the cosine of twice an angle. Kind of interesting. Okay. Also, though, if sine squared of theta plus cosine of theta, sine squared of theta plus cosine squared of theta is equal to 1, I could also say that sine squared of theta, I could subtract cosine squared of theta from both sides and say that sine squared of theta is equal to 1 minus cosine squared of theta, okay? And if you did that, so I would have cosine squared of theta, okay? I'd be subtracting, I'm gonna put 1 minus cosine squared of theta in place of sine squared of theta. So that'd be 1 minus cosine squared of theta. And you have to be real careful when you simplify this. You're going to be subtracting 1. You're going to be subtracting a negative cosine squared of theta. So that's going to give me a cosine squared of theta minus 1 plus cosine squared of theta. Notice I have 2 cosine squareds of theta and a minus 1. Okay, so that's 2 cosine squared of theta minus 1, okay? So there's a way that you can get cosine of twice an angle if you just know the cosine value. There's a way that you can get cosine of twice an angle if you just know the sine value. And there's a way that you can get cosine of twice the angle if you know both the sine and the cosine. So hypothetically, you really should memorize all of these. We're not going to work with them a ton this year, but especially if you're on the academic team, you need to know these. So anyway, long term though, you'll all need to know these for pre-cal.